Hello friends, in this video let us look into algebra of complex numbers. We have already defined complex numbers. We have seen what is modulus of a complex number and what is amplitude of a complex number. Now let us see what exactly we can do with these complex numbers. I mean addition, subtraction, multiplication and division of complex number. And before we go for addition, multiplication, division or subtraction of complex number, I mean algebra of complex numbers, let us first define what exactly is conjugate and also what do we mean by equality of complex numbers. Let's look into this. We have already seen that a complex number is of the form z is equal to x plus iy. Here, x is called the real part of the complex number and y is called imaginary part of the complex number. Fine. Now, modulus of the complex number is already defined to be square root of x square plus y square, as well as amplitude or argument of the complex number or amplitude of the complex number z is defined to be tan inverse of y by x. We have seen this. Now, interestingly, first point is the conjugate of a complex number. Conjugate of a complex number. If z is equal to x plus iy be any complex number, be any complex number, then the complex number usually denoted by z bar equals to x minus iy. If z is x plus iy, the complex number z bar equal to x minus iy is called the conjugate of z. Conjugate of z and vice versa. Which means z bar is the conjugate of z as well as z is the conjugate of z bar. So these two are the conjugates of each other. X plus iy and x minus iy are the conjugates of each other. For example, if z is 2 plus I, if z is 2 plus I, then the conjugate z bar will be z bar, this is conjugate z bar will be 2 minus I. 2 minus I, the sign of the imaginary part to be changed. So for example, if z1 is 3 minus 2i, then z1 bar becomes 3 plus 2i. The sign of the imaginary part to be changed. If z3 is, or z2 is 7, what must be the conjugate of this complex number? There is no imaginary part at all. So z2 bar will be just 7 itself, because 7 means 7 plus 0i and conjugate will be 7 minus 0i. Nothing but 7 only. So that is how we define conjugate. And interestingly, the complex number z and its conjugate z bar always having same modulus. Modulus of the complex number z and modulus of z bar are always equal. Now, second point which I wanted to teach you in this particular video is equality of complex numbers. If you have two complex numbers, x1 plus iy1, first complex number, and the second complex number, x2 plus iy2, these two complex numbers are said to be equal. Two complex numbers are said to be equal if x1 is equal to x2 and y1 is equal to y2. What is the meaning of this? It means two complex numbers are always equal when their real parts are equal as well as imaginary parts are respectively equal. Real parts must be equal as well as imaginary parts are equal. Then we say that two complex numbers are equal. So for example, if I have the complex number z1 to be 2 plus 4i and z2 to be 2 plus iy. Whenever I say that z1 is equal to z2, it is as simple as real part equal to real part. No doubt about that. Both are equal, as well as imaginary part equal to imaginary part. What is the meaning of imaginary part equal to imaginary part? It means y is equal to 2. So, it's very important to understand that two complex numbers are equal only if the real parts as well as imaginary parts are respectively equal to each other. So that is what equality of two complex numbers. Now we will come into the important point of algebra of complex numbers. Algebra of complex numbers. Algebra of complex numbers is nothing but addition, subtraction, multiplication and division. Addition, subtraction, multiplication and division. In fact, before I go to algebra of complex numbers, whatever addition, multiplication, subtraction and division, I'd like to teach you what exactly is the powers of I. We know that I is exactly square root of minus 1. I is an imaginary number which is exactly square root of minus 1. Now, what is I square? Obviously, I square directly becomes minus 1. Square root of minus 1 whole square, it becomes minus 1. What about I cube then? I cube will be I square into I. I square into I will be minus 1 into I. You understand that I cube is minus I. I power 4. I power 4 will be I square into I square, which is minus 1 into minus 1, which is 1. Here one cycle is completed. I square is minus 1, I cube is minus I, and I power 4 is 1. Again, if you come back to I power 5, you get back I power 4 into I, which is I power 4 is 1, you get back I power 5. So I power 6 becomes minus 1, I power 7 becomes minus I power 8 becomes 1, that continues. Always remember that I to the power 4n is always 1. I to the power multiple of 4. I power 4, I power 8, I power 12, I power 16, all these are always equal to 1. Interestingly, what will be 1 by I? 1 by I. If you have 1 by I, you can just multiply and divide by I again. The numerator is I into 1, which is I. Denominator is I into I, which is I square. I square is minus 1. So 1 by I is nothing but minus I. You must know this. 1 by I is exactly equal to minus I. We must know 1 by I also. Now, based on this, let me come back to algebra of complex number. Let us see what exactly is the meaning of addition and subtraction of complex numbers. Suppose if I have two complex numbers, if z1 is the complex number x1 plus iy1 and z2 is the complex number x2 plus iy2. Let us see how exactly these two complex numbers can be added or subtracted. Remember, z1 plus z2 will be, it is x1 plus iy1 plus x2 plus iy2. The addition is done based on you should add real parts separately as well as imaginary parts separately. When we add real parts separately, it will be x1 plus x2 plus, when we add imaginary parts, underlined terms separately, iy1 plus iy2, which is exactly I into y1 plus y2. This is addition of complex numbers where you will go for addition of real parts, sum of real parts and sum of imaginary parts separately. In an exactly similar way, subtraction can also be done. Whenever you subtract, you subtract real parts and imaginary parts separately. For example, just look into this. If z1 is minus 3 plus 4i and z2 is 2 plus 2i, let us take it as 2 plus 2i, what exactly will be z1 plus z2? z1 plus z2 is nothing but you add real parts separately. Minus 3 plus 2 is minus 1 and add imaginary parts separately. 4i plus 2i is 6i. This is sum. Whereas z1 minus z2 will be, you subtract real parts. Minus 3 minus 2 becomes minus 5 and 4 minus 2, that will be 2i. 4 minus 2. So, addition and subtraction of complex numbers is nothing but addition of real parts plus addition of imaginary parts, as well as subtraction is also subtraction of real and imaginary parts respectively. So this is the most important thing in algebra of complex numbers, addition and subtraction. We must even see the multiplication and division also as a part of complex number. In this video, we have seen what is the meaning of conjugate of a complex number, what are the meaning of equality of complex numbers, and in the part of algebra of complex number, we have defined addition and subtraction of complex numbers with examples. These are the basics of complex numbers and very, very important concept to understand complex numbers in depth. Thank you.